Here are the solutions with work and explanations to the problems I gave you, the AP practice problems from pages 177 to 179. Let's take a look at number 4. So it's been a while, but we've definitely seen problems like this, especially when we started working with the chain rule. So what we could do is just rewrite the function to help us out. So we could just say this is cosine of 4x, and then that whole quantity is cubed. That way we could apply the chain rule a little bit easier. So then our derivative would become 3 times this quantity, cosine of 4x, squared. Then we take the derivative of the next inside stuff. So the derivative of cosine of 4x would become negative sine of 4x. And then the innermost stuff, derivative of 4x, would just be times 4. And then we clean this up a little bit, because if you notice what we have here, we're going to get a 3 times a negative 1 times 4. So there's a negative 12. What's nice, that's the only one, but let's just make sure. We do have a cosine. We can rewrite it this way, cosine square of 4x, and then times sine of 4x. So that matches B. All right, for number 8, we're asked to find a trapezoidal approximation. Now, if you notice, the distances between 0 to 2, 2, 4, 4, 6, they're all 2, so we could definitely use the trapezoidal rule. So we're going to have the distance is going to be, well, using the formula for trapezoids, we'll have 1/2, and then the height would just be a 2. And because the height is consistent here, we'll just start with 4. Then we'll have plus 2k plus 2 times 8. So our job is to find the value of k, and then just plus the 12 at the end. But they tell us that it's equal to 52, so what is the value of k? So we'll just have 52 is equal to, this will just become a 1. So we'll just have 4 plus 16 plus 12. So that'll give us 32 plus 2k. That'll give us 20 is equal to 2k, and k is equal to 10. Okay, for number 9, we have a velocity function given to us, and we're referring back to position of a particle. So a particle moves along the x-axis so that any time t greater than 0, its velocity is given by v of t here. If the particle is at position x equals 7 at times t equals 1, so it's like an initial condition or just a condition that we have to use to help us find a constant, what is the position of the particle at time t equals 2? So we're going to start, even though it's multiple choice, I still want to show you the proper steps. Since it's using x here, we'll just say x of t is equal to the integral of v of t dt. So then that becomes the integral of 4 minus 6t squared dt. So it becomes 4t. We could start by just writing minus 6t cubed over 3 and then plus c. So this simplifies to 4t minus 2t cubed plus c. Then we'll use our initial condition. So this is really saying x of 1 is equal to 7. So we'll set this equal to 7. T is 1, so we'll have 4 times 1 minus 2, 1 cubed is just 2, so we'll have 4 minus 2 plus c, and c would equal 5. So now we have x of t is equal to 4t. We could rearrange this if you really wanted to. 4t minus 2t cubed plus 5, and then we want to find x of 2. So this will give us 8. And then 2 cubed is 8, so we'll have 8 minus 16 plus 5. Negative 8 plus 5 is negative 3, so there's C. All right, then looking at 10, we're given this graph and we're given a function here. The figure above shows a portion of the graph of f. Which of the following could be the values of the constants a and b? So this is really taking our knowledge of asymptotes and where they come from and putting them back into the function here to help us find the values of a and b. So I want to start first with the vertical asymptote. Vertical asymptotes always come from the denominators of a rational function, and it occurs when the denominator is equal to 0. So our vertical asymptote is x equals 2. So in order to find b, we're going to substitute in the 2 for x. So we'll just get 4 plus b is equal to 0, therefore b is equal to -4. Now what's nice, I'm still going to show you how to find a, but we only have one value of b at -4, so we could kind of jump to that conclusion here. But we're going to take the horizontal asymptote, which is y equals 3, and that occurs, remember, limits at infinity is how we can also calculate the horizontal asymptotes. So if I were to take the limit as x increases without bound of ax squared plus 12 over x squared plus b, and then the shortcut here, this is going to equal 3. The shortcut here is because the degrees of the numerator and denominator are the same, I don't have to worry about anything else. It's just going to be a over 1, so then a would equal 3, and that confirms our answer for D.